Is this visible? No.
Not yet.
Is this visible now?
Yes, it is visible.
Yes, yes.
Okay.
Good.
Great,
Congratulations, Professor.
Thank you.
Thank you very much. Thank you. Yes.
I think it's for all of us. Visible?
Only thing is that I want it, since the slides are more, to be, how do I signal you? That's all.
Visible now?
Yes, it is visible. Yes, yes.
Okay. Yes.
Good.
Great,
Congratulations, Professor.
And,
Oh, why is there an echo?
Thank you.
and just a little announcement, madam. Professor
Only thing
name
is that I want it, since the slides are more, to be, how do I signal you?
I think you can just say next, next, next. That's fine. That's the only way at the moment, because I may not be able to see you, or you won't be able to see me either. So it will be difficult to, because the screen is occupying the slide will occupy most of the screen.
Okay.
It's fine.
So next we can just have to say, or
Right.
it is understood that when we cover the portion, you go to the next.
Right.
It's like that, is it? Huh?
You just say next, and
Okay.
I will shift the
That's-
slide.
That's fine. That's fine.
All right. So Dr. Lal, are we ready to begin? I think we can then.
I think leaving the formality,
Yeah.
but introduce a little to Dr. Teli. Instead of saying much about Nishti, you introduce Dr.
Right.
Teli. And then I will say a few words about Dr. Teli, and then we can begin.
Right.
Is it this full screen, madam? Or
No, I will put it on full screen. I
Okay,
just
afterward,
want to
afterward.
get
Okay.
your introduction done. Then I will.
Okay. Okay.
Okay, sir.
Okay.
Dr. Yadav, I'm wondering whether all the people have come onto the.
52, 62, 60 people have
madam.
come.
They've come in.
And I made you as co-host, as a host, so you can manage it. And we are live now on the YouTube.
All right.
Yeah, please go ahead.
So,
Excuse me.
good evening, everyone. Today we have a very prominent speaker from the field of textile chemistry, who's going to talk to us about the drivers of development in the field of textile processing. Dr. Professor M.D. Teli has a huge amount of experience in his background, and I'm quickly going to just tell you a few things about him. Professor M.D. Teli is a professor of textile chemistry, and he has been a senior most professor in ICT, UDCT. He's also been a former member of Board of Management of Institute of Chemical Technology, Mumbai, and former dean as well as head of textile department of ICT. He has teaching and research experience for 39 years and has been awarded with CSIR CNRS France, which is on International Research Fellowship for doing research in France, and GDR Academic Exchange Fellowship in Germany. He has many credentials of papers to his name. To name just a few, he has 328 research publications and has published in over 85 international and 33 national research papers. He's been a recipient of number of honors such as TAI Ratna and Honorary Fellowship of Textiles Associations of India, Academic Excellence Award Fellowship of Maharashtra Academy of Sciences, TAI Ratna. It is my pleasure to welcome Professor M.D. Teli to deliver the webinar. Sir, the platform is yours.
Thank you, ma'am.
Let me say something before you start,
Yes,
Professor
please.
Teli.
Yeah.
I wonder what to say about Dr. Teli. We are friends for long. I don't remember for long. We've been in touch with each other in my 19 years stay at Mumbai and thereafter also. Dr. Teli doesn't need any introduction. He is an authority in textile processing and known world over. He has been working in various university of international level, and he has so many patents to his credit. And one patent recently he has been awarded, that is on mosquito repellent dyes and its process of dyeing. That has been awarded to him from 21st April 2015 for 20 years. And this patent certificate has been issued to him on 14/9/2022. So Dr. Teli, though you have so many credits to your account, but again I would I would myself congratulate you, and I hope that all the participants will join with me to congratulate you for your new credential. Dr. Teli has been a very social also. Not only Dr. Teli, his family also is very social, and he believes in Vasudhaiva Kutumbakam. He will, during his talk also, he will say a few words about it, and you will learn from there. He is not a simple man on the earth. He is above that. So Dr. Teli, not taking much time of participants, I would request you to start and benefit the participants with your experience and expertise. Dr. Teli.
Good afternoon, friends. Am I audible? Huh?
Yeah.
I'm audible. Okay. So, friends, first of all, at the outset, I apologize for whatever the delay which is caused because of the setting of this computer and this, but then Professor Nim and all you, the organizers, were so much helpful to me, because end of the day, we have the knowledge, but if it doesn't reach you, then it's of no use. With regard to my, my conscious belief, I truly believe in the philosophy of Vasudhaiva Kutumbakam. And that is what it, easy one today in the globalized world. Unless you believe in that, it is not easy to get, success, because you need to have the same, the kind of attention to be paid to everyone without, the discriminating anyone. And then for us as the teachers, that is what is a basic requirement, and that's what I followed. And I do feel that the purpose of very life is to serve the society, because we have some kind of a purpose behind our creation. So that's what I believe. Okay, next,
Dr. Teli, yeah. Professor Kushal Sen is also there.
Yeah. Oh,
yeah.
So welcome, sir.
Thank you very much.
Thank you. Basically through these lectures, we can see each other, face to face, because I, last time I missed him when I came to So shall we go to the next slide now, because the slides are more. Wow. So if you look at India, it's a young nation, and we have, I think my request is participants should mute their mind.
Participant, all of you mute your you mute yourself, all the participants.
All participants are requested to please mute your mics.
Yeah, please mute your
audio.
Yeah, please mute your mic. So that, okay. So India is a young nation, and you can see, the 66% of the population, if you see, is again below 35 years. The age and increasing standard of living we are, observing. There is surplus disposable income. Everyone is now becoming even brand conscious, and an improved quality of life. So naturally, it's an aspirational society. Next.
Yes, 1 minute.
Yeah. The present, so as the lecture is concerned, this we will have some kind of we look at what is the present status of this textile business, what are the governing factors of this business, internal and external conditions of the business, then consumer expectation about the product, some kind of a responsibility towards the shareholder, the people and planet, as far as any business is concerned. So that's we call as 3 Ps. And then compliance to the laws of the land where business is carried out. And we also haven't to be forgetting that it's a free market economy, it's a globalized business. If our domestic, the consumers, it is, earlier days they were forced to buy the Indian goods whether the standard is good or not, but now they can choose themselves because global brands are available. So global textile market, we all know these figures. I wouldn't want to spend more on this, but there is a compounded growth which is going to happen between this 2014 to 2020 or 6.6. And next slide. About 1,200 billion is the trade over there. So market size somewhere between 1,000 to 1,200 billion. Right now is 1,032 billion. But then this will increase by 2030 about 1,420 billion. Anticipated to grow by about 4% CAGR. And then since there is availability of e-commerce, so this facility, so the trade will grow still further. And smart fabrics when it comes to technical textile and various materials. So far presently, this bill, 1.46 billion is the market, but this will also increase by 30% CAGR, and that's about 5.54 billion by 2025. Next. So Indian textile and apparel and handicraft industry status, if we think, it contributes now because the overall our, the GDP level is increasing. So it's just 2% of the GDP, 7% of the total industrial output, 11.4% share in India's total export. And domestic textile and apparel textile industry presently is about 103 billion, is 2021 and figures, and export about 44 billion. And it is again expected to go, grow to a double figure about by 25-26. Next. So if you look at India's position, because end of the day, where do we stand in relation to the various countries in the world? And India is either, if you go in the global production as well as market, because it is also a market, big market. So in fiber, yarn, fabric, garment, and retail, I'll not go through reading each one, but India is somewhere in the second position. You will most of the places after China. Next. So when there is a policy of China plus one for the, seeing the sourcing of, various international companies are looking for, different sources, and China plus one policy is giving a great opportunity for India. India's position in textile fiber production, #1 producer in cotton jute, #2 in polyester silk, #3 producer of viscose rayon, #4 in nylon and acrylic. And 95% of the hand-woven fabric which is produced in the world, that has been from India. And about 5 crore people which were employed in the value chain of textile. And 11.4% is the export revenue which is earned. And if we look at it, presently the population of the global population is about 7 billion. And the consumer, the per capita the consumption 5.2 kg for India, but almost overall they are saying about 7 kg per person. So 7 kg into again 7 billion people of the of the globe. So around 49 to 50 billion kilograms of the fabric is to be manufactured, and for which how much meterage, if you consider per meter 3 fabric, 3 meter per kg fabrics, and that is the voluminous job which is to be being produced in the world. Next. So these are the various segments. I will not go into details. So you can just look at it because everyone is conscious about apparel wear, home decor, outdoor coverages, and so on. And then there are 12 segments of medical, the technical textiles. The next slide will indicate that. Next. So these are the various segments. And here again, the new opportunity comes. It's about 16 billion, the business. And research and development, or we talk about innovation. And, so that is here is another area where we need to, a lot of research is being done and will be required to be done. Next. So what are the requirements of business today? Because whichever field one wants to do the business, first of all, has to be a cost competitive, because then only you will get the demand for your product. Then highest level of international quality. So quality, international quality doesn't become a choice, but it has to be a basically accepted factor. Then response to fast changing fashions, because customers, the demand for fashion change is always there. The maintenance of delivery schedule is another thing. Even if you have agreed to supply them, but you supply them on a proper delivery schedule which is accepted, otherwise your consignment is not taken. The appropriate and advanced technology one has to use. Minimum level of utility of water, because if at all you want to reduce on the cost, you want to have the good quality, all these things have to be taken. Production process and product compliant to the laws of the land. And wherever we are supplying, there also those products should also be free of any red listed substances. Next. So it's a good agenda for research and development. Present situation, as I was talking about, the volume is 7 kg per capita consumption needs 50 billion kilograms or 150 billion meter fabric production all over the globe. And that much fabric being used in a different form, and then it is to be disposed of. So unless and until we subscribe to the elements of sustainability, reduce, reuse, recycle, restore, replenish, and it is not by choice. It is not by choice, but it is because we are, compelled to do that. Only then our future will be somehow or the other secure. Development that meets the needs of the present, which we have proper right to do that, but without compromising the ability of future generation to meet their own needs. And actually, if you see it, the future generations, their whatever the promise which we are already spoiled it. So now what we have to do is that if any additional efforts we want to do, we have to see that we don't add more, the carbon footprints to these, and we have to be conscious about. Next slide. Yeah, next one, because it has another add to that. So everyone on one side, we see that how much I have nothing to wear, or so much of affluent people consuming the garments. On the other side, also you will find, next slide, you see that people are having, next slide. There are people who are devoid of any clothing. So this kind of the extremes are existing, and they're somehow the other, unless and until we, in our own mind, we become conscious. So it is not that business. For the business, it is a different philosophy. I'll come to that next. So we have to see that at the farm level, when the fiber which are produced, minimum impact and efficient farming to be done, fiber should be produced with a minimum utility, rationalized ETP plants, and so on. Fabric, then we can use the renewable resources. In the fabric, having an efficient design. Finish should also prevent wastage, and the fashion, which meet expectations of the brand and apply synergy. So these are the certain sustainability goals. Next. So human wants are never ending. Here again, one has to, whether you like to be philosophical or not, but you have to, realize that this is what which is right now happening. So as far as needs are concerned, more are they same, but the wants are going on swelling, and the environment as a whole is the victim. So, and if they are limited. If we limit our, the wants, the other thing is that the business will shrink. So it's a diametrically opposite. That's a dichotomy existing, opposite goals. But one has to see that while we create the wealth, but at the same time we do not deteriorate our environment, and also the worsen the conditions of manufacturing. Next. So the impact of human activity, whatever these activities you are dealing in, population increases, economic growth is happening, but all these red, the arrows, which are, actually attacking the earth, air, water, land pollution, ozone layer depletion, global warming, loss of biodiversity, and resource depletion. So all this is also happening. And so we have to somehow the other to find out the balance, and that is where the technological advances may be able to help us. So two opposite kind of forces are working here. Next. Next. Yeah, so is this and this is a kind of a thing, is a business as usual practice in the management. They call this word inverted comma business as usual. The way we have been doing the business, can we go along like that? So it's a profitability is at the top, and we are not bothered about the environment degradation or also the people who are stakeholder and what is their future. Next. So we have to change that. And as far as coming back to the textile value chain at a glance, 72% of the water consumption is happening in the process and is due to the process water. And these are the various processes from fiber to yarn to size yarn to weaving to wet pre-treatment. Then we go to dyeing and printing, then goods preparation, everywhere. And basically in the wet or processing, the majority of the water is consumed there. Next. So the wastewater which is generated from the textile mills, it's not my subject right now to concentrate on what are the various, the pollutant in the, but desizing, sizing, curing, bleaching, mercerizing, various these pollutants are existing. So again, that water, when we are leaving out from the dye house, the process house, it has to be first fully treated, and then only it has to be, connected to the seaway. Next. Yeah, next. Next. Yeah, so in general, we can see this is a linear economy on the left side. Then we can produce, sometimes we recycling, we can think about the element of recycling. So produce, use, and suppose for some to certain extent possible to recycle. And now we are talking about the circular economy, the recycle, again use it, again reuse it. So reuse, redesign, repair. So as far as sustainability is concerned, one has to be conscious of, while being successful from the economic side, one has to also be conscious about planet and the people and their safety. Next. So this just now I discussed this, what are the sustainability goals. Next, farm to fashion. So innovation has made our life more comfortable. We must accept that, not that we only did the bad thing. While we were doing this industrial revolution and different type of the technological application which were adopted to make our life better, and it has made our life better. The only thing we have not been conscious about is what happened to our environment, what happened to the stakeholders where we are manufacturing it, or the workers who are involved in manufacturing. So while we accept that the more comfortable, the life has been created because of the innovation, but we now need to invest that our technologies have to be have to be looked at in a little more conscious way and in a micro way. Come on, next. So changing trends in the consumer wardrobe. Earlier, 10 years ago, we will say that the wardrobe of consumer was more based on the need-based clothing, shirts, trousers, jackets, and all. Now it is more or less because they're, the lifestyle is improving. So they want a special wear for the sports and specific ethnic wear, casual wear, office gear wear, night wear, and so on. So it's a more of a occasion specific. And after 10 years, maybe again, it would be a design-based assortment and a fast fashion, eco-friendly apparel. So this will keep changing, Next. Demand from the consumer will keep changing. And they will also require additional, as the consumer is, becoming enlightened about the existence of various fabrics and the various technologies, So easy care, shape retention, comfort feel, wrinkle resistance, dimensional stability. So even a general common consumer is becoming more and more aware of these. So fading effect. And so consumer will expect it. Or specialty finishes like flame retardancy, water and oil repellency, stain repellency, antimicrobial finishes. This kind of desired effect, which will be, which will be desired by the consumers, and they will ask for it. Next. So the value addition by creating this desired effect, would be again one of the necessity. And here technology has got a lot of scope for comfort, for sustainability, protection and safety from UV absorbance or anti-allergy. I just now mentioned about it. Or some of the clothing which have got the aroma, some special finishes like mosquito repellency, and so on. Next. So in the whole technology, textile, apparel, and as the textile fabric and apparel production process, there are a lot of complexity. There are different varied number of substrate. As the substrate change, the dye stuff will change, and then their absorbency level will change. And accordingly, the required utility also will change. The machines required for processing this, they also change. Auxiliaries will change, and so on. So there's a lot of complexity. Next. So when we see a look at the drivers of the research and development, drivers for this research and development, so that we could reduce the cycle time, the water requirement, energy requirement, chemicals requirement, dyes requirement, effluent load also to be decreased, and the production cost. So the new technologies which are being developed, they are developed with this particular goal, that finally end of the day, they should give us reduction in all these, the parameter. And so that we can increase the profitability and decrease its impact on the environment. So the goal is to be faster, to be economical, and less effluent load. Yeah. So advanced dyeing overview I'm talking about, and I think most of you know, but the only thing is that they have not become, these technologies have not become as common on the shop floor. So many a time, some of them are, but many of times we, do not know or do not give much attention. But then, of course, in the various educational institutions also they are introduced. Ultrasonic assisted dyeing, E-control, supercritical carbon dioxide, electrochemical dyeing, air dye techniques, and so on. So let's go through hurriedly. My intention of this lecture is to create an awareness that what is there available, and it will depend upon who is interested in what and what are the various conditions. That's how I conclude it. So let's go to the next slide. Like the conventional dyeing, where we know what are the problems, are conventional. It's a lot of water consuming, and there is the dyes and the chemicals, and a lot of energy also required. So of course there is a big load on the carbon footprint. Next. But then came people become more conscious as the water is becoming costly. So the minimum liquor application techniques came in. And that is where we started then talking about, minimum, we should design the machines in such a way that the liquor, earlier was liquor, stationary, fabric moving, then came fabric, stationary, liquor moving. And then we are talking about liquor and fabric, both in motion. So there is a uniform dye, but at the same time, it could be in the tubular form so that the material to liquor ratio is reduced to a great extent, and the quantity of chemical, quantity of dyes, and quantity of auxiliaries could be reduced. Then there were also various recommendations of padding and squeezing is always used, spraying technology, coating technology, and foam application techniques. They also came in. And this foam technology, in fact, at certain point of time in the industry was being used for, dyeing and printing also. Next. Next. So the foam application technique where fabric is padded with the foam, and this foam is formed from an aqueous solution of a dye stuff and a foaming agent and a carrier. So the white fabric goes through this, and then padded fabric is then maintained at an elevated temperature to fix the dye. The proper selection of foaming agent and the foam application is required, and then the properly foam applicators are also properly adjusted. Next. And there are various designs of these machines. This is a doctor blade, and the foam, how the foam is applied on, and then it is regulated. So foam, of course, carries the dye along with the air. So that's how it is. Foam is formed, and then that is applied on the surface of the fabric, and then finally it is squeezed and rolled. And so it is what that minimum liquor has been transferred. Dye liquor, maybe in this case, has been transferred to the fabric. So you want a less energy for drying it, and so accordingly a lot of cost reduction and the faster production is possible, and the continuous operation is also possible. Next. So requirement of foaming agents, again, we don't want to go into details because it's a good wettability has to be there. It has to also give the good, uniform size of the, the foaming bubbles, and should be compatible with other products. And it should, all the foaming agents which we use should not deteriorate finally the dye property or dye performance property on the fabric. So advantage of the processes, the short dyeing time due to shorter drying and fixation time, increase in productivity, and so on. Next. It can be used for finishing and printing also. Next. So air dye technique is another one. This is more or less restricted by cholera. In Canada, they have, no chemical works within the minute, doesn't, the water is over, air is then going to be the future. Next. So next one. Air dye technology manages the application of color to the textile without the use of water. It was developed and patented by Colorado, a California-based sustainable, manufacturing company. The air dye process employs air instead of water to help the dyes penetrate in the fiber, and process that uses no water. So the technology works only on synthetic material, because as we all know that only synthetic material at such a high temperature, the dye in the fumes or the sublime form can be accepted. The same is the way we do it for the sublistatic printing. So air dye technology heats up the fabric, then injects the dye, and we get the dyed whatever. Next. This is the one, but airflow dyeing machine. You can see the dye without use of water. Next. The advantages, you have different disadvantages, because if air dye uses 95% less water, 86% less energy, and these are all advantages. Environmental way contributes 84% less to the global, the warming. Economics, air dye process reduces waste as 10% of the traditional, and so on. Next. So this is so far it kept in a more or less in a very secretive patented technology it is, and it is with that company. Supercritical critical fluid or carbon dioxide dyeing machine. This is more or less for so many years, last 2 decades, or more than 2 decades have been talked about, and higher, bigger and bigger industrial versions are made available. Next. And Dyco, that is a Turkish company, has put up a plant with in Malaysia, and I think number of places it could be there. And I also got to know that even Colortex is working with Dyco. So this where they are selecting the proper dyes, because you need a proper selection of a dispersed dye. This works only on the synthetic fiber, and where the pressure is almost 73 atmospheric pressure, use the carbon dioxide is used here, and it is temperature is 31.6%. So that is the supercritical conditions for carbon dioxide, where it is liquefied. So, so that, you know, it can diffuse inside the fiber along with the dye. And dye, you know, the distribution in the fabric is so well that you don't have to use any auxiliaries. So it's a low cost, non-toxic, recycling up to 90% is possible, non-explosive. Only the thing is that pressure is very, very high. Use is required there. Next. So, dyeing with supercritical carbon dioxide, where the carbon dioxide and polyester, of course, the sample or any synthetic fiber, one can dye. Next, I have talked about this. Next, let's go to the, yeah. So if you see the conditions, and this is the at the right side, there supercritical region in the orange, you know, the square it is suggested. So in that region, we are about 31.1 degrees Celsius temperature and 73.8 bar pressure, the carbon dioxide remains in the supercritical form. So that way you can carry out the dyeing. And once the dyeing is over, then again the pressure could be released, you know, in the side tank, and then whatever the dye which was in the liquid form can be again obtained in the powder form. So almost no water is a waterless dyeing, and no auxiliaries you need to use, and so on. Okay. Next. So dyeing with I talked about it, so I'm not going to this. Next one. Next slide. So this is conventional water dyeing and the dyeing with supercritical carbon dioxide. And so here also when I spoke about this, don't worry. Next one. Next. Only thing is that it has a limitation, is that the investment is high pressure is required. There's a little data available about dye stuff, because you cannot get all the dispersed dyes to be soluble into supercritical carbon. That's one. So one has to be selective, and that's how the color text is having, you know, the collaboration with DyeQ, the machine manufacturer. At present, it is being done for synthetic fibers because dispersed dyes can be applied. Reactive wet and direct dyes are not soluble in supercritical carbon dioxide. So, you know, and trying to also get them apply on the natural fibers, which require the breaking of hydrogen bond, which is not possible by supercritical carbon dioxide. But some work is going on in this direction. If it could be, you know, the fiber can be modified and then it could be made use of. Next. So ultrasonic assisted dyeing is another technology where ultrasonic shows compression, rarefaction during each cycle of wave. And somebody's, yeah. When ultrasonic waves are absorbed in liquid system, may I request some friends to put your mic on mute? It's disturbing.
Please see some disturbances coming from somebody's side.
Yeah. Somebody is attending two things, maybe. Okay, please. Okay, so ultrasonic assisted dyeing here, cavitation is the alternate wave formation, oscillation, collapse. We'll go to the next slide. You will get to little more during. Put further, press further. So here you can see that earlier, just one back. I'll see the figure. So when ultrasound waves are absorbed in the liquid system, the phenomena of cavitation, the bubbling, cavitation takes place. Cavitation can liberate entrapped gases from liquid, a porous material like textile and diaper. So you can see this compression wave with the second one, the blue one. First one, so you need a sonicator, so who can produce the sound. And then there will be, so the dye leaker, which will go through the various, you know, the sizes of bubbles. And at the time of compression, they will burst off. And when there is a rarefaction, there will go on swelling. So this is how that energy, ultrasonic energy, helps one to get the dye diffused into the fiber. And whatever the dyeing which conventionally we do at a particular, suppose 80 degree or 90 degree, you can do it almost 20 or 30 degrees less. temperature. So you can save the that much, the thermal energy. Come on, next. So, and the phenomena which is explained there is that first the dye is getting dispersed because of the ultrasonication. So the dye, when it is dissolved, the aggregates are quite big. So when with the ultrasonic waves, they get dispersed, so the micelles get. Then degassing of the fabric takes place. So if there is a gas inside the fiber pores and all, that also goes off. And then the diffusion is accelerated inside the fabric. So that's how the good dyeing can be obtained. Next, or penetration of the chemicals could be obtained. So the diffusion of the dye takes place in the activated state only. Next. Okay. Advantage: energy saving due to the low temperature, reduce process time, reduce effluent load, and real-time control is possible of the color shade. Limitation is ultrasound technique. Really, it is useful in the laboratory and on the smaller scale, but when it comes to the commercial level, where those transducers or the sonicator, they have to be there. They're kind of the manufacturing and getting the higher surface area becomes a challenge. Next. So far it is not that highly commercial. Of course, in certain fields, ultrasonic is quite common. E-control is, everyone knows about this process, which is industrially accepted, widely accepted, but only because it is expensive, the big companies have this e-control system. And this is the outcome of technology developed control between the Dystar and Monfrod's Thermex. Those are the machine manufacturer. These together, they have developed this. A simple lab process and reproducibility allow a quick response. Rapid batch changes are possible because of using this e-control. Next. And if you see simply, the complete fixation of the reactive dye is in the normal case does not happen in the normal drying conditions for Leofix and Remazole dye. But then next, if when it was studied, it was found that if the humidity is 25% and the air temperature is about 120 degrees, fabric temperature only remains about, by this graph also you can see, remains about 68 degrees Celsius. The actual fixation takes place from year to year, and that requires a higher humidity. So when the humidity of the air which is used for drying is, if it is higher, then one gets a higher 71 degrees Celsius temperature, and that is where the faster fixation can occur. And e-control has been successful in showing that kind of these are the recipes. Here you are not using any of the salt and these dyes, and you have the wetting agent and anti-magnetic agents and soda ash, the alkali, for fixation of reactive dye. Next. And you will find this is a normal pad dry, pad steam process. And here there are almost 25 variables in dye application, IR pre-drying, then hot fluid drying, alkali application, steaming, and wash off. Next. But when you go using the e-control system, normally you have only dye application, then the IR pre-drying is happening, and there is one bath in which you pass the fabric through. So temperature, time, humidity, only those controls you need to do it. So 40% fewer variables, only 16 variables are there, and then washing off. So this is only possible because of the e-control process doesn't have too many variables. Come on, next. And if we compare, the time required in normal pad dry, pad steam process, 34 minutes. Here it is 22 minutes required. So a lot of the e-control process is faster, better production, and also savings are happening. Next. This is in pad dry, pad steam. So you can see that amount of the salt which is required use. And here there is no salt use, and e-control saves the lot of saving it shows. So this is one of the comparison how e-control compares with vis-a-vis pad dry, pad steam process. Next. Then we are talking about again microwave, the dye. And next, it saves processing time, saves in energy. But so far, microwaves also, if you see, These microwaves are electromagnetic waves whose frequency ranges from 1000 megahertz to 10 lakh megahertz. So it makes use of the dielectric property, which refers to the intrinsic electrical properties that affect the dyeing by dipolar rotation of the dye and influences the microwave field upon the dipoles. Next. So, actually you see from the center to around the microwave when the heating is happening. Whereas in our conventional heating, the outside container heats, then the next layer, and then the next layer, and then the next layer. That's how it goes. So microwave, from the very core, you get the proper heating, and so it processes faster. Next. And in this, of course, one can, depending upon the, go to the next. This is also not necessary to explain. Next one. So go to next. Just a bit. So as far as microwave dyeing is concerned, so far it has been useful, and it is being used in many of the laboratories. Most of the research laboratories, also in the companies, in the individual companies' laboratories, where the shades are developed. So they develop these shades in the microwave using making use of microwave dye, because this is faster. But when it comes to the the industrial application, where so far it is much limited, and hardly it is being used on the industrial level, microwave dyeing, I mean. There is another one is electrochemical dye, and this electrochemical dye, which makes use of the the reduction process. So this, like, electrolysis is what is done with a dye and what liquor. And we have some of the dyes, VAT and sulfur, they are not soluble in water. And so to make them soluble, we need to reduce them first. And that reduction, normally we use sodium hydrosulfide, which is not an eco-friendly reducing agent. And that is the reason this electrochemical dyeing has been proposed. Next. And then there are 2-3 methods. One is a direct electrochemical dyeing and another indirect electrochemical dyeing. In case of direct electrochemical dyeing technique, organic dyestuffs have been directly reduced by contact between dye and the electrode. Indirect electrochemical dyeing, where in the reduction technique, the reduction of the dye is achieved through the redox mediator system. So you have to use another redox mediator system. I have to limit my the explanation of each of this process, basically looking at the time, which is right now it is 4:49, and so total available time and the kind of the information which I want to share. So if anyone wants to go into the details, Google is there, or anywhere you can find out this information in the textile books. And so please pardon me if I am not going into detail. There is, as I mentioned, the direct electrochemical dyeing. The dye stuff is partially reduced by using conventional reducing agent. Then complete dye reduction is achieved by electrochemical process. Next, the B part, next one, is indirect electrochemical dyeing, where the indirect electrochemical reduction technique, the reduction of the dye is achieved through a redox initiator. First, the reducing agent reduces the dye, and it itself gets oxidized. And it is this reducing agent afterwards gets further reduced at the cathode. And that's how indirect way it is done. Next. It has also the limitation that dye stuff particles must come into contact with the electrode surface in order to get reduced. The dye itself must be reduced at the surface of the cathode. Next. Limitations are, these are the limits. Actual reduction of the cells should be carried out separately in the electrochemical cells, and so on. Next, there are many these, the limitations. Economically, as we say, ecologically, it's a great advantage that you don't have to use those kind of a non-eco-friendly, the reducing agent. Not totally they are replaced, but to certain 90% is replaced. So health-wise is it better, but economy-wise, and one has to be also conscious about how we can use it, and whether it is in the regular day-to-day processing of VAT dyeing and sulfur dye, is it possible or not? Next. So it has to make an economical sense too. The laser treatment, again, using laser for dyeing, and specifically now it is used for mainly the etching of the denim garments and so on. So each technology has got a specific advantages on certain specific area of the value addition in textile. Not that they can be, used for every single effect to be obtained and every single operation. No. Laser treatment next. So it is something like light amplification by stimulated emission of radiation. Here it is achieved without, without affecting the thermal and mechanical properties. Is one advantages, and affected properties include particle adhesion, wettability, optical properties, and so on. Next. So possible application textile, your application for removal of indigo dye, and that is being used. It's very, very widely used. Creating patterns on textile to change their dyeability, producing the surface roughness, cutting textile waves. So laser technology is being used relatively much widely, and laser irradiation on polymer surface is also used to generate a modified surface morphology. Weighting properties and optical appearance also is changed. Next. So on polyester, on polypropylene, these are the effects that by that way we can increase their dyeability, extent of dyeability. Of course, in polypropylene, it has its own, again, the challenges because the fiber is very highly crystalline. So one has to also additionally, modify the polypropylene. Next. This is one of the effect of laser application. I had few videos, but I can't show because so much of thing is to be shared and very limited time. Next. So advantages of laser, we can say laser treatment, if they are quite, understandable. Treatment leads to increased dye uptake with the same amount of dye used. Laser technology again can be used for creating these various specific effects, hydrophilic group, specific, the finishing nowadays. Next. Somebody is talking. Chirag. Chirag, please keep your mouth.
Hello.
Chirag Saab, please mute your mic. Okay. So next one. Yeah, this is again now heat transfer printing. It is a very old one. Many of us know about it, but then one has to see that what are its effects, and it is doing great job as far as the, the printing of shirts, various, the printed T-shirts and all these are printed. So heat transfer printing, where basically the technology is that the whole your, the patch gets transferred onto the fabric, and it is because of the heat. And earlier we also that it has got number of the, the next slide. It has got number of different heat transfer printing or sublistatic printing. The paper was earlier, earlier when we talk about, in 1978, 80, Mr. Garad also was knowing there in Katao, the Japanese, the paper, heat transfer printing paper used to be imported. There the design was there on the paper. And these papers contain the dispersed dyes. And with the heat, thermal effect and the pressure, the whole thing can be transferred on the fabric. And many of the saris and all were printed with the heat transfer printing paper. So we call it the regular, the heat transfer printing. So transfer printing was also acting like a Xerox machine. Now the latest, another one is a digital printing. Again, there are different kinds of machines. And now what the biggest challenge was only the speed. But now they have almost acquired from about 18 meters per minute to almost they have gone to 100 meters per minute. That kind of a thing is there. But this is for special effects, and you don't have to use the screen. You don't have to use, and it's a more or less a dry process. The newest method of fabric printing, it is like inkjet printing with a computer, but rolls the fabric to extra wide, the printer. Next. These are digitally printed fabric. This is the machine, and various machine manufacturers are there. And this is again, this has seen the day, and people are using it widely. This technology is being used widely. Next. Fabric printing. Come on, next. So these are the various types of digital printing machine where the little principles little differ. Then next. Yeah, then I was told little about to also cover something about nanotechnology, and is like something like we are talking about 10 raised to minus 9 meter. So 1 billionth of a meter, and that is the labor. And it has been found that any material, if it, like for example the gold, so-called we say it is yellow, but then it's a size. If it goes on decreasing, you can see the central one. This is the only gold particle, but because it is size in nanometers is differing, it is giving the different colors. So you can imagine if you have a bath or you have a technology where this gold, you know, these nanoparticles could be deposited on wood. Chirag sir, please, Mr. Chirag, please mute your mic. You know, this is disturbing us. So what is happening is that if suppose this kind of a, you know, the nanoparticles, they are, you know, of course, wool or such materials, they are absorbed, then you will have, where of course the colored fabric.
B2S but actually B for Bombay. B2S.
Someone is disturbing the whole process. Please mute your mic.
Is it
Please
Chirag?
mute your mic.
Chirag Panchigar. Chirag?
Chirag, it is mute. Somebody else is talking.
Somebody else is okay. So please look into that. So what happens is this nanomaterial, you know, in Victoria University also, they developed nano and silver, and they carried out dyeing of wool, and different various beautiful shades were obtained. And in addition to this dye shade, but it also was, you know, the antibacterial, because these are the materials which are, they kill the bacteria. And the same is in Israel. When I was talking about this nanotechnology, I gave the lecture there. They develop again the nano sensors, and they say artificial. They actually called it as artificial nose, and it was mainly used for detection of cancer in some individual's breath. So what they have to do, they would go to the hotel, the hospitals, and they will collect the breath, exhaled air. They will collect, and with the nano sensor developed, they will then accordingly see the images, and they will, with the artificial intelligence, they would connect and predict whether that individual is going to have cancer or not. So it's a pre-prediction, and they were quite successful in that. Next. So the nanotechnology does give you a number of advantages. Textile fiber technical applications. We have nanofiber, nanocomposite fibers, nano emulsions. If you carry out dyeing through this or finishing through nano emulsion, then the properties are totally different. And same is for superhydrophobicity, UV protection, anti-static finish, flame retardant, antibacterial finish, using the nanomaterial. And I sourced last maybe 15 years, my laboratory also we have been working. And worldwide also many of the research, a lot of research is being done on the application of nanotechnology in textile field. Okay, next. So, and various, this nanotechnology in the form of nano emulsion, nano coating, or electrospinning, and subsequently many further, this technology of nano coating further subdivided into layer by layer, sol gel, plasma, and so on. Next. So I will not again go into detail. I'm just enlisting it so that you will have an idea that what is a nanofiber is. Many times everybody is using again for sensors. One of my now last PhD, who she's submitting her thesis, she's working on this nanofibers, and which will be acting as the dye sensors. So nano dyeing, nano finishing, this is how, and then UV protection. Let's go to next slide. Some of the slides explain this further. And this is which we are talking about this, the morphostructure without using any textile dyes or color. Just the way the butterfly, the wings, they are so beautifully colored, just because of the specific geometry of the structure of the, the wings. And that's how you get the different color effect though there is not a single colored pigment. So this all is actually we are imitating the nature, and most of the the Japanese inventions are based on inspiration from the nature. Next. Yeah. So dyeing with nanoparticle, Teijin Fibers Limited, Japan, they produce Morphotex, a first optical coloring fiber that mimics the morpho butter wheat. And there is no dye here, but you get the various bluish this shade without the color. Next. The dyable polypropylene, this again, as I said, is that where we use nano clay, and polypropylene itself also was modified, and you can get the dyable polypropylene. Otherwise, polypropylene getting dyed is also difficult. Next. And conventional methods used to impart different types of, the nanotechnology has real commercial potential for the textile industry. Nanoparticles have a large surface area. That is the one of the why it works well is it has got a very large surface area, very minute, the dimension, high surface energy, and because of that, any material, any finish, when it is applied on the fabric, then you don't have the breathability is not reduced. Whereas in the conventional finishing, the breathability is reduced, the comfort property is reduced, and also so-called the properties which we are talking about. Suppose, for example, a given fabric is, the antibacterial, or the given fabric is UV resistant. These properties then, after washing, these properties go away or totally deteriorated. Whereas in the case of nano finishes, this does not happen. And your properties are quite fast and, to washing. Next. So there are many such kind of materials available. One can also find out details about nanotechs, antibacterial property, anti-static property, or UV protection properties. Soma, next. So this is again, we are talking about the water droplet was initial one, the earlier one. Yeah, the on the lotus leaf, how the water droplets, they just take all the dirt and roll them because it is because of the nano crates which are there on the surface of the basically the lotus leaf, and that's the same effect is here, the imitated. Next. Here, this is again for a photocatalysis effect using nano titanium dioxide, and the nano titanium dioxide helps here when it is excited to decompose in the presence of light. What happens is decomposes the organic dirt, and because so it is something called as a self-cleaning fabric. Once you have this finish given to that, the fabric need not be washed. Of course, it still might have the odor or something. People may not still prefer it, but it has been proposed that this is a self-cleaning, and yes, this technology is quite famous. Then silver, if it is used, silver nanoparticles, in the encapsulated form, in the left side here, encapsulated form, and then these capsules, these are silver nanoparticles, again give you the antibacterial property. Next. Yeah, anti-static properties of nano titanium dioxide, use nano zinc oxide, again antibacterial property. For flame retardants, you have a nano antimony dioxide, and nano titanium dioxide for your photocatalytic effects, and so on. Next. So UV protection is possible. Next. This is how the sun protection one can. Then application of plasma technology. Next. The plasma here is again the post state of matter, and so it contains ionized gas, then positively and negatively charged ions, and then you also have the neutral active molecules are there. So it's a mixture of all that. Next. And this is also quite old that way, 3-4 decades over. But then application wise now, as the people are aware that where and what we can use it accordingly, this application makes the difference. So it's where here the gases, even in our research, we have used non-polymerizing gases like helium, argon, air, oxygen, nitrogen. Polymerizing gases are also used as a fluorocarbons and so on. Next. So these are the various plasmas which we see here. And next. Yeah, next. So what, as far as textile fabric production and then treatment with plasma is concerned, what we should do, of course, there are various plasma application equipment, wherein most of them are vacuum based are there. So they're under, under low pressure, then the plasma created. But we needed to make it more, applicable in a day-to-day process. Atmospheric pressure plasma is needed, and that is some of the equipments are now available and people are using it. No, not so widely, but still they are there. Next. And this is where, the plasma carries out the etching. And if the plasma, when it carries the etching of the surface, at that same time that there is a polymerizing gas, then the surface would be also functionalized. So functionalization also takes place. Next. So next. So these are the, of course, you don't go into detail this, so we have extra. Yeah. This is where, again, the commercial plasma treatment equipment. Next. Yeah, this is when go back. The lab label, the earlier slide here. So the textile material, this goes from here to here. This is the plasma zone where the plasma is created. And along with that, if you want to give a, functionalization, so some gas also like chlorofluorocarbon and so on. So this all is there, dielectric plasma developer, barrier discharge plasma, and your fabric is modified here. Technically, it's modified, and then that is how it shows a different, the effect. It behaves differently. All the positive properties are imparted to it. Next. So with the use of, okay, let's go to next one. This helium, halogen, helium plus nitrogen. These are the various colors of those plasma. Next. And what happens is here that we can see that dielectric barrier discharge plasma we got here. These are all actually the experimental way, untreated fabric. When it was not treated, this is a hydrophobic fabric, not treated. But then when it was plasma treated, subsequently it shows the hydrophilicity increase. This is a plasma treated, this is a untreated, then plasma treated. So absorption level of this polyester, again, plasma treated. And in the case of silk also, so hydrophilicity improvement could be possible. Okay, next. Here again, the picture of the dye bath after exhaustion. So this is in the case of silk, the nitrogen gas was used there. So number of these hydrophilic groups are increased. And so you can see that at a lower temperature, the exhaustion, finally the dye bath almost becomes, the clear, So various control way the plasma treatment is carried out. Next. So you can see this, the exhaustion goes up to almost close to 95% of the exact plasma treated sample at 40 degrees Celsius. This is low temperature dyeing of silk fabric using atmospheric pressure, helium and nitrogen. And it was because there is a nitrogen, so amino group content is also increased, and because of the plasma treatment, you can do it. In a normal untreated sample, you can still have the exhaustion is much lower, the dyeing So dyeing temperature could be reduced by plasma, better properties could be obtained. Next. Similarly, it is possible, just the way hydrophilic, you can make it hydrophobic, and then Refron. For that, the gas Refron is used, which is again, the chloro-difluoromethane, and that gives you again the fluorine atoms connected to the fabric, and then you get the hydrophobic property. Next. So these are the various controls. Next. So this is why the untreated, and when it is treated, you see that the water droplet completely rolls off. So that is hydrophobicity is imparted because you are using your helium and fluorocarbon, this one FC plasma treated sample. So that's how. Next. This is plasma treatment effect, the hydrophobic finishing of silk fabric by plasma. So you can imagine your silk saree or silk material, if it is plasma treated, and it happens only on the surface, so the strength is not compromised. And at the same time, because it is almost water, hydrophobic, so naturally it is also stain resistant. If your curry or your coffee falls on the saree or material, still you can just shake it off and nothing will happen to the main cap. Next. These are again another similar way how the hydrophobicity is imparted. Next. So good scope for this technology. It is green process, dry process, less up amount of so many other advantages ecologically are there. Next. Next. And then I'll just hurriedly go through some of these another 5-7 minutes. These are the specialty effects. I will not read for you because it takes my time. Go further. I will just look at some of the slides. These effects, we know that these are the various effects which are desired by the present day modern consumer. Okay, next. So antibacterial finishing of textiles, and the odor formation is happening because on the textile. So so all these bacteria which are developed, contamination risk is there and all. So we have to have the antibacterial finishing. Next. And there are various ways. I just put them into the slides in case I had time. But so this is recent development, conventional finishing. Next. Because these are again from the literature, various companies have developed. These they don't give the formulation, but like earlier for wool finishing, shrink resistant chlorination process are used. Now it is in a sustainable way. It is not sustainability compliant. So this oxidative pre-treatment of wool is carried out. Then biomimicking is done. In the novel finishes. Earlier it was mainly these fluorocarbon and silicone polymers were used, ultra hydrophobic surfaces. Now again the lotus effect is obtained. Next. We'll go through this fast. So Sandoz have got some of the chemicals which are available, and companies, or this Dewan chemical is giving halogen-free flame retardant, where they are also using nanotechnology, encapsulating the microscopic amounts of flame retardant particles and so on. Next, because bromophenols cannot be used. Then there is aromatherapy, cosmetotherapy, and insect repellent, as a lot of work is being done. Then this is graphene. Graphene again is on the nanoscale, and one of the dimension of it is on the nano level. So it's like a carbon, one carbon atom thick kind of a material. How strong? It's very strong. How thick it is? 1,000,000 times thinner than paper. How strong it is? Stronger than diamond, graphene sheet. But how conductive it is better than copper. But at the same time, it has got the foliation, so that doesn't have between the two layers the binding. Next, that's the problem. Next. So, and graphene can be used again in semiconductors, energy electrodes, and so on. Heat, various, science, engineering, and technology. You can see LEDs and all. And one of my students, of course, they worked on, again, getting the graphene, not necessarily getting from outside. So synthesis of graphene oxide and then further reducing it. The graph of, next. What he did, I think we can see the pictorial kind of, so you have the graphite oxide, which is cheaper, then you convert it, treatment with a graphite oxide to graphene. Key driver, so yeah. Then the biotechnology, again, I don't want to introduce and spend time more on this, because we all know that biotechnological, these all enzymes and various enzymes have got different, the chemical principles on which they bring about maybe desizing or scouring, or sometimes even removal of hydrogen peroxide, so catalysis kind of enzymes and so on. Let's go into, we are not going in details. Next. So use of enzymes. So desizing, scouring, bleaching, dyeing, finishing. All this bio bleaching is also done where hydrogen peroxide is cleaned up. Biostoning, that biopolishing is done with cellulase and lactase and so on. And there are microbial colorants. Now this is again, these are the latest in the sense that microbes give the dye. And this dye, when it is applied on the fabric, you have more or less, this is more or less a sustainable kind of a dyeing phenomenon. And biomimicry in textile, we all know this. Where next, you know, how the weaving has come out from inspiration of spider web or the knitting, and even from cocoon, of silk cocoon, this non-woven technology. Yes, next. This lotus effect, which I was talking about. And now the technologies are using the very construction of lotus leaf for their, you know, the creating those nano crates and finishing it, you know, with a you know, hydrophobic finish, so that they get a super hydrophobic material. And lastly, this is the last set of, you know, natural dyes. Let's go, because everyone knows about natural dyes, but we cannot discount them, although they are available in limited. Next is because here is one research that is published only from this mungfali or uska jo cover hai chilka, you know, so they got a color. Next. So these are so many you can see in the literature and available. Even this is the National Institute of Fashion Technology in Patna. One of my students is lecturer there. So he shared with me this kind of effect, you know, with roasted peanut skin. Next. This is with, you know, chickpea. Same. And then they found out it is not, he did not wait only for the color effect. It is important that he developed and said that, and it has antibacterial property. It has UV protective property, you know. So you have a coloration and this added to finishing property. Most of the things he has found out. And this publication is there available on the industrial, you know, problem. Shades of chicken pig. Next. Yeah, eucalyptus tree bark also. Next. Go next. These are various shades. So, and here is, you know, we all have the coconut water in Bombay. Also, we take it here. The waste outside that coconut, you know, the shell. Now we take the shell extract, and if the untreated fabric put into, you can get a good dyeing effect, and different pH if you dye, different color shades you can obtain. And it is not our purpose is to get the dyed effect, but in addition, what we get is next slide, that the fabric then moderated. Next. And these are the various chemicals in that, you know, the extract. And finally, what we get is a fire retardant property. Can you imagine a good fire retardant property? Then you have the, and you know, the UV protective effect also can be obtained by using this. And this is also, all these are published, ACS, Sustainable Chemistry and Journal. This is published literature. Okay. And the fastness properties are quite good. This is the experience of our own in using this this material. Eco-friendly single, then insect repellent finishes we developed. Okay. Next. Yeah. Go to next. Go further. These various emulsions again from the, you know, that coconut shell, and this extract is used. Along with, he used chrysanthemum fragrance, and this is a, you know, and a specific binder, and one can get a mosquito repellent material too. So this is a pad, dry and cure technique is used. Next. And this is how, when he used this from, this is just a waste material of that, you know, the coconut. Finally, you have that fabric. Well, please go back one slide. That fabric which you get is mosquito repellent, antibacterial, ultraviolet protective. It has an aroma because you have used this mosquito repellent, and natural coloration. So there are a lot of such kind of pieces are available. Next. So the advantage is that this can even contribute to Atmanirbhar, you know, India, because since you have Amazon, anybody can produce as per the order this type of materials or the garments, and then just on the order one can give it and sell it, because not because they are going to compete with the shades or the fashions of the garment available in the market, free market, but these are specific value-added clothing. So I can conclude saying that different technological choices are available. Each of these technologies are unique, and I feel that they have advantages and also limitations. We cannot say this is the best technology and so on. Their promise is not universal, but dependent upon the situation of the processor, the lot size, return on investment, final price agreed in a given market, whom you are catering to, which kind of market you are catering to, so on. Geographical location of production as well as sale, and then specific segment of textile being catered. Volume is equally important, and value which you are getting, that's also important. So among all these technologies discussed, the one commercialized also need to be decided about where and when they are to be beneficial to. So we cannot use that, say that, okay, we have a continuous whole range for dyeing or, the finishing, so I can use it even for the smaller lot. You can't. If you use it, it's not at all economic. So the question is not which is the best technology, but our own common sense has to be employed. We have to really, the processor, that's why a robot will not work here to have choice of a technology, to decide which could be the most appropriate technology to be used in the given circumstance. But that sensible decision, one has to be making that, has to be based on informed knowledge. And I think with this lecture, I have tried my best, to contribute to the general depository of our knowledge. Most of these technologies you all were new, or you knew it, but I tried my best to just refresh your memories and bring it to your notice. Thank you so much. And special my thanks to Ramashreji and NISTI organizers. And as I always end saying that, because end of the day, if I have to thank all of you, the best way is to thank you is to say that I will remember you in prayers. And so next time when I visit a lotus temple, of which I am a director, one of the trustees of that, I will surely remember all of you who are the participant of this seminar in my prayers. Those who believe in God should be happy about it. Those who don't need prayers, still I will be praying for them.
Thank you, Professor Teli.
Yeah.
I'm sure you need to take a glass of water. You've been talking non-stop for an hour and a half, and that's a lot of information for all of us. We are actually thrilled by the amount we have learned today, but we will be ready to take questions for you in a short while. The moment I would request all those who want to ask questions to raise your hands. Oh, we already have hands raised here. So, sir, if you're ready, you want to take
Yes.
All right. May I request Mr. Vilas Gharat to please ask your question.
Dr. Teli.
Yes.
Yeah, wonderful. It's a huge presentation. And I know this 1 hour is very less for you to complete all these things.
Yeah.
Especially for nanotechnology, what you have said. Yeah, of course, you have to go hurriedly. So my just request to you, if you can give this presentation to us or NISTI, I think we will be enlightened more. Then we can ask some questions on your mail.
No problem. Yes.
Because there are a lot of things to what you have said about the coconut.
Yes.
And there are many things which we were not knowing at all.
And most of these are published, so it is in the public domain. I can, share with you. Yes.
And thank you very much.
Nanotechnology part, no?
Yes. That's a.
Thank you, Vilasji. I'll go to the next questionnaire. Ms. Reena Krishan, please go ahead and ask your question.
Thank you, sir. Thank you for such a wonderful presentation. Sir, you have been my professor 30 years ago at Sophia's. I learned technical theory from you. Yes.
Right.
Sir, I have just started a natural dyed clothing brand called Repeat.
Uh-huh.
And I have been like, when I started, I was very, shouting loudly that I'm not using chemicals and I'm not polluting. I'm right now settled in Bangalore, so we have
Mm.
our frothing lake, and it was just
Mm.
a singular focus.
Mm.
Now today you have talked so much about, and I have been in touch with Daiku also,
Mhm.
though they are doing in large quantities, but
Mm.
I was requesting them, people like me, I want to bring in natural dyeing with less water. So
Mhm.
where is it that we can go and experiment? Because Daiku said that
Mm.
Bombay Textile
Mm.
Research has a
Mm.
pilot machine.
Mm.
But if people like
Ah,
us
ah,
still
ah,
want to be sustainable and
ah.
understand which is better, because for me, according to our
Mm.
superficial knowledge,
Mm.
polyester microfibers were the biggest pollutants.
Mhm. Yeah,
Now,
yeah,
all the things that you've said, which where the carbon footprint is better,
yeah.
people like me wouldn't understand which one to take, whether it's cotton with more water or whether
Mm.
it's polyester, which is going to pollute.
Mm.
So then, where do we strike a balance, and how do we understand which one to use?
You know that as you just, first of all, let me correct you. I'm not sure Bitra has a small level of equipment, but Mantra, Sasmira has. I am on their
Sasmira,
research
Sasmira,
advisor.
sorry, yes, Sasmira.
Sasmira has it. That's at Worli, and they were developing now bigger and bigger units. So if you at all you want to somewhere try and give it a try, they can help you. Because finally their intention was to develop such kind of a supercritical carbon dioxide unit in which dyeing can be done, and possibly. But that
Because
is
I do a lot of shibori and things, so I thought in that we can try out various textures.
Right.
But right now, sustainability is a very rich man's
Yeah.
world, like
Yes, absolutely.
MOQ, the
Absolutely.
machine cost. So how are we? I mean, everybody wants to be sustainable, but how does one reach there?
No, I tell you frankly, the one can never be 100% sustainable. It is not possible. It is only our system which God has produced. If you see from our body, how from our embryo conception, we grow and then we eat. Suppose I eat banana, then I have ice cream, then I have meat, I have every single, you change any raw material, put it in me or you, and then it is converted to energy and all that thing. Where is such kind of a sustainable system? And then one day I die, could be again put into grave, and that is totally sustainable. That's where, so that kind of a sustainability.
So then they start calling it greenwashing, when we say that I'm doing natural dyeing, and then they come into that.
So no, I am not saying that the natural dyeing where we cannot do sustainability. There is an extent. You can be 50%. So you can reduce the work. Like I am, helping one of the social enterprise in Mumbai on this natural dye. In fact, I was first technical consultant, and this social enterprise is working with the slum ladies, and what they are doing is that, they got idea, they are taking the flowers from
temple flowers,
flowers from our Siddhi Vinayak. They have made an agreement.
Yes.
Take those all
Adi pure
temple
nature.
flowers. Adi pure nature. I was a consultant. Rupa is
lovely,
my friend.
lovely.
Rupa is my friend. This boy also, some of these boys, they learn there. But actually, and then earlier when you do the natural dyeing in a real sense, it is quite cumbersome. It's quite cumbersome. That means even the fabric desizing means use cow dung, and even natural indigo, you use different process. I gave them, because I work about almost 12 years. End of the day, you are dealing with a chemical. Finally it is chemical. So glucose. Suppose you have a glucose, or suppose you do the reducing. It is not that it is not because it is chemical, so it is totally, it's not non-eco-friendly, not so.
They use alum.
They use alum, and many things are being used. So actually we shorten the process. A normal case, 15 to 20 days for a particular shade is to be developed. We do it in 2 or 3 hours, and still I say 100% equally with the same consciousness that it is naturally dyed. Because there are other people who use in that shade the acid dye or other chemical and synthetic dyes. No. Or they use certain objectionable like chrome or other, the moderns. which are
Copper
objectionable.
sulfate.
And then you get
Lead.
a different shades, but that is not which we intend. So this Adi pure or many, they are using something which is can be substantiated that it is pure, but at the same time in a most technologically advanced way.
So the same thing is happening even with organic cotton.
Mm.
Now people claim it's organic, but we are not understanding which testing lab to trust. We do not know once it reaches there, will it get rejected from their testing? So how does one control all this?
That is where, you know, those who have the label manufacturers with the certification, proper got certification is there. From there only you can buy. But as you say that sustainability is not only technological issue. Sustainability is the issue of personal commitment to ethics. As you say that, because if I am not ethical, I have a certification which I will hang that certificate in my industry. But simultaneously, I can use, the non-sustainable ways because I want to make more money. So this is where one has to see that do I remain totally ethical into seeing it. So I am saying is that your water, the consumption, your energy consumption, your chemicals which you are using, totally compliant chemicals. This all you have to look into it, and then you have to be,
So is there any agency which calculates carbon footprint that is approachable
there is also,
for people like us?
There are also courses, and on the web also you will find out how to calculate this. There is even Arcoma, they are available. That now it is a simple technique. Some of our students have taken a course, 2 months or 3 months course, and you calculate this. That's difficult aspect. And as I tell you, that you cannot go and aim for total sustainable product. What you need to do is that earlier, by that conventional method, if you are having the 100%, the unsustainable way, you can reduce it by 50% is also a good contribution.
Thank you, sir.
And
so
then
can we get in touch with you if required?
Sure.
You share your email with us.
Anytime. My share
Thank
is
you.
Yeah.
Thank you, Reena ji. Let's go to Abhishek ji. Please unmute yourself and ask your question.
Yeah, hello, sir. Hi. Thank you so much for the informative session. And thank you again for keeping us in your prayers. I'm also a textile processing student from GCTI Kanpur, and I've been working in the textile industry from the last 5 or 6 years. I just have one quick question that with so many recent developments and so many technologies, especially being brought into the textile processing field, why still, especially the well-established brands or their suppliers are not using extensively these for these technologies? Can you throw some light on the main challenges that are being faced in India or in other countries?
One of the challenges, like for example, one of the great textile mill, I don't want to name it, and Ramesh Reji is knowing, and we're quite famous of continuous processing unit. And in when I was doing for Ministry of Textile Technology Upgradation Fund scheme and so on, so we used to send our students also continuous way of textile processing, where it was like a, what we could say, it was like an elephant, which needs also the input so much so that it can give you the proper production, because high speed, continuous way you can manufacture it. But nowadays in the fashion, like I don't say ladies only, we all of us, when we go for buying, then we first, the cost is important, definitely. At the same time, in the same style, we want 10 different colors. You understand? Now the fabric or the garment with 10 different colors in the same style, it has to come. Earlier, lot size used to be 20,000 meters. Now he will say, yes, I have given you 20,000 meter lot size. In fact, the owner of that company, I told him that I want to visit and see functioning. And actually, when I visited and I saw it, see 20,000 meter ka fabric to aapne liya. But afterwards, what he is doing is that 4 shades, 4 colors. So it became actually a lot. Kitne ka hoga? 5,000 ka.
Right.
और उसमें भी 3 शेड, हर एक एक कलर में 3 शेड, तो लॉट कितना होगा 1,500 का, और 1,500 के लिए also they are using this. So workers are not losing, the company is losing. Workers are creating impression that we are going on the brand is happy that we, so actually many a times I am not against any brand or anything, but I work, I was advisor for SAC, Sustainable Apparel Coalition. And I was one from India, the others were from different countries, like 5 or 6 of us. And at that time, if you remember, a few years back in Bangladesh, there was a fire, and in apparel, textile, if you garments, Bangladesh is much ahead. But then, because of their high productivity and low cost of production, what happens is, because of that, the fire accident definitely, because people just go at any cost, go on manufacturing without looking into or investing into safety aspects and so on. So I asked their question saying that, how about you as a brand give additional some kind of the incentive for following a sustainable way, in supply chain. So if you don't, and you have to again that penny wise, they have to again compete on that money, then how do you get it? You see now, suppose the other day somebody said that so and so politicians wearing 32,000 rupees shirt. Now I, in my own life, I have done it. And just Gucci, just because it is Gucci, the total cost is never 32. Ramashrey ji or aap sab log mujhe bata sakte hain maximum kitna hoga? Real cost, which is good. Maybe not even 1,000 or 1,000.
Not more than 500, Dr.
But better quality bola, sab kuch hai to 1,000. So 31,000 are going to the brand just because, of course they have their expenses, but not so much. If they give the slice of their such an exorbitant profit to little to that manufacturer, then that manufacturer also have suppliers, isn't it? They have their own suppliers, then they will share that profit. Actually, this is not happening. The consciousness among brand is driving the agenda, but making the manufacturers to go through cutthroat competition. That's not fair. That's absolutely not fair. And that is where the ethics here. If I was having a brand, I wouldn't do it.
Okay.
Thank you.
That's it.
Thank you.
Thank you, sir.
Thank you.
May I invite Professor Sheshadri Ramkumar to please ask your question?
Now two stalwarts. Time is not there. Otherwise, we would have debated. We would have given them platform to debate on Vedas and prayers and everything. Not only technology. Dr. Sheshadri Ramkumar. Thank you so much for joining us.
Professor Teli, it's early morning for me, but I got to tell you, first and foremost, I just want to thank you for doing this. And it's 30 years since I met you when you visited us in Leeds.
Yeah.
That's when I knew about Baha'i and Pranam. Nice. And I'm also very thankful to Dr. Lal and all other colleagues for doing this. This is sustainability. Sir, let me cut to the chase. I am really thrilled to know that you said sustainability is relative. That is very good. But what is that is lagging? Whether it's relative or total, let's not debate it. But I'm really thrilled that you said sustainability is a relative terminology. What is that from global industrial perspective that is lagging for the industry to take sustainability? Is it a lack of technology per se? Because supercritical carbon dioxide is not universal. It's not for cotton yet.
Yeah.
Plasma, continuous process are just developing. Is it technology lag? Or is it awareness, or is it the cost? What is that is basically?
Of course, there are, for example, even to get technology developed, you need to make the investment. Today, if you make the investment in order to have the technology which will give us that, the latitude of processing the textile in a sustainable way, so there has to be that investment done. But now, and the manufacturing hub is come to India, all this poor, relatively not affluent. I wouldn't say India poor, but relatively not affluent countries, isn't it? And we have to manufacture and then feed them. Actually, that is the reason most of the time why we are manufacturing more. And they could definitely say that we are not polluting our right now. That is the issue. So it's the money of the brand, and they are doing good job. I say they are becoming responsible. They are giving the business to the people, manufacturers. But my only query is that they themselves also advocate. They should invest in many of these, the technology development. They should also see that if their suppliers who are from India or Vietnam, if they are not able to give them the proper kind of products fully developed in a sustainable way, what is their what is their problem? They should see that concept, and you will come to know that it is because they don't have leg room, because their the whole business is on cost competition, cost cutting. Because I have spoken to many of the manufacturers and suppliers, they say, sir, additional kuch 2 cent or 4 cent. In Ludhiana, they told me also, they are not willing to give. Now, if you are as a brand, you can definitely command a particular value, then you should also be. So it's again, as I said, it's their commitment to, they are committed, but they are committed also is because of, that, there are various activists which are there on their head, so they need to do it, At the end of the day, it is
there is disturbance from somebody's side.
There is some
mute yourself.
So your question is very right. Technology, I can't say that all technologies are well, they are developed, but these technologies to be developed fully. Some of them are like like digital printing. Now, if I want a digital dye, don't use printing. The complete, the same method, same thing, but totally a dyed effect. You can get it by printing. Correct? No? Now, to do that, and it is very, very easy. You can shift it, fashion change, all those various today's business parameters can be still, addressed to. But then for such machines and to be employed, and fashion changes are faster, the lot size are different. And as I again said, certain things you can do only batch wise, certain by semi batch wise, and certain by continuous way. You cannot, like, if I have to pick up my pen, I cannot get an elephant to pick up the. I have to pick up with a small, they're my own fingers. It's a complex issue, but it is not that we cannot address it. And end of the day is we have to be conscious of all these depleting resources.
Dr. Teli and Dr. Ram Kumar, Sheshadi Ram Kumar, you must be knowing Dr. H.S. Das, Additional Textile Commissioner. He is there listening you.
Yeah,
Dr. Harsharam Das.
Thank you, sir. Good evening, sir.
Thank you.
Dr. Ram Kumar also made him well.
Yes, sir. And I'm really thankful to Dr. Lal.
Thank you.
Having served as a very high position in the government, people just retire off, but he is trying to give back to the society. Vardhatam, Abhivardhatam. Thank you, sir.
Thank you so much, Dr. Ram Kumar. You are taking out time for us and joining us. That is itself very great. You are sitting at USA. Is it hot at Texas?
No, sir, it is getting cold now. It's getting cold. Fall has started, so it's cold.
On your bike, I'm seeing the fan. Thank you, Dr. Ram Kumar.
Thank you
so much.
Thank you, Professor Teli. Thank you, Professor.
Let Professor Shanbag and Dr. Kuldeep Sharma say
I'd like to invite Dr. Vinod Shanbag, the ex-chairman of NISTI, to sum up the webinar today. Dr. Shanbag, are you around?
And Dr. Kuldeep, you can invite.
Right, sir. Okay, it seems Dr. Shanbag is not around. So may I invite Dr. Kuldeep Sharma to say a few words?
Good evening, colleagues and Very good evening to the guest. Dr. Teli has taken us down to the memory lane, back to the classroom. And I feel that this is fundamentals of technology in the textile processing, though I have not been a student of the textile processing. But by virtue of experience in the industry, some fundamentals have been cleared. We are so lucky to have Professor Ram Kumar, you, and some more stalwarts. And I see today Shri Ram Nivas Sharma, who has been doyen of the textile industry, spinning industry. And I have already welcomed you here, sir. The whole idea of inviting people of your stature is that you see the NIST profile across, right from the students here to the entrepreneur and to the technocrats, techno-entrepreneurs, technocrats who are now mentoring textile projects also and are giving contribution to the textile industry. Our presentation has been so excellent that it gives an opportunity to the youngsters, young entrepreneurs to delve into these areas, and that would not have been possible for us to guide unless a person of a caliber or skill set associate with us with this profile of Textile Institute corporate members as well as individual members area. So possibly you can think of identifying some of the technologies which we take on our platform for the purpose of young entrepreneurs, and with your mentorship can contribute to the industry and the nation's program of the Make in India initiative. NIST has the acumen to delve into this area right from beginning. We have identified technologies, commercialized them, taken entrepreneurs, those who are prospective entrepreneurs to come into this area, especially in technical textiles, medical textiles. And you know it very well. I don't have to take much of the time because in many of our conferences you were there. And so if this crusade can be taken ahead now onwards with your association and with your august appearance and with this audience with us and our members, this will be a great benefit and service to the fraternity to all. With these words, I thank you all of us, my colleagues, the executive committee members, and the initiative of the chairman, Dr. Rama Srilal, who every month at least organizing one such webinar which is useful to the industry, and sometimes 2 webinars in a month, and contributing to the textile industry. Thank you very much, and looking forward with the great association on this platform. Thank you very much.
Thank you.
Thank you, Dr. Sharma. Sir, Dr. Lal, would you like to say a few words before we give the vote of thanks?
Dr. Kuldeep Kumar Sharma has already covered many things which I wanted to say. Okay. And Dr. Sheshadri Ram Kumar is here, whose presence is really very encouraging to us. Dr. Harsharan Das, I already told that though he is an IAS officer, he has been attending almost all seminars, webinars of us. And it is a great privilege for us. He is joining and he is giving over time. There are so many persons, so many stalwarts who have joined today's webinar. It is difficult to name them all. Professors are there from GCTI, Arun Gangwar, Arun Patra, and so many. I need not a Balaji, Director APC, Senior Director APC Bangalore. He always makes it a point to join this our webinars. So we have been able to percolate all over India, and that has been the objective of NIST. The executive committee has planned and programmed that we should spread our wings to all India rather than being restricted to North India section. So thank you, Professor Nian. You have been conducting our sessions very well. And I get a lot of relaxation when you are there. And today, Dr. Vijay, I think he has joined back, perhaps.
Yes.
Yes,
I see Dr.
Dr. Sorry, Dr. Vijay Yadav. Dr. Vijay Yadav, he has been very sincere. He had a meeting in the MSDE today. He prepared everything for us. He initiated and saw that there is no problem. And then only he went to attend the meeting. And now he is back. So I would request him to say a vote of thanks and a few words from him. Dr. Yadav, please. Is he there?
So we want Teli sir's email ID if someone can put it on the chat.
I think, yeah, I can. Shall I say it?
On chat.
Chat, I can. Yes, I can chat. Put it on chat. Yes.
Reena is a real entrepreneur you have created, no? Reena, the experience which I have with the natural dyes, I am sorry to say that no one in India is doing actually natural, not actual vegetable processes. Somewhere or other, you are on mute, Reena.
I do it myself.
You do it by yourself. There may be only few, because
there are few are there.
There are few who are maintaining the
I
tradition.
was trained at the Calico Museum, the Sarabhais, and the Weaver Service Center, Ahmedabad.
Good.
I learned it.
Maicha was there that time?
No, there was a one SK Datta was the head of Weaver Service Center.
Datta.
Yes.
So I do it properly. But the thing is, you need a lot of money for it because you can't sit with your stock.
Reena, you don't know what you are doing because Reena, you don't know where you are. See, all the things are not available and it is not possible. The indigo dye which you are using, it is not really natural.
I know. Yes.
Similarly, for reduction of that indigo,
I use that flower, the clitoris blue flower. I don't use indigo.
So if Dr. Yadav is not there, I should say thank to everybody, and including Professor Teli, who has done a marathon webinar. Thank you, sir. You have obliged me by accepting my request. Though you are very busy, not only in India, internationally, it was very difficult to get your time, but ultimately you have made it. I lost a hope that we will be able to get you, but you yourself contacted me that Lal Sahab आपने बोला और आप बोलोगे आपकी बात नहीं मानी. You now fix it up.
This cannot happen. We cannot forget our grassroots, and our
yes. We had very good association in Bombay and is still continuing almost. So thank you everyone.
And my special thanks to Neelan madam.
Nian, yes. She is the backbone of
the lecture.
So you still haven't typed your email?
I typed in this one. So they went to.
You have to press enter.
No, I did that, but I think it went to Kiran today. Now, so I have to. Who is direct message?
No, to all you say. I will find out.
I'll do that. Okay. To all, I'll do.
Everyone. Sir, it felt exactly the way you were teaching us in school. It's the same, the way you presented. It's so good.
I have Shri to all, everyone, It's just like you. You're writing. You write Mangesh 95 Teli at.
Acha, MD Teli.
Mangesh.
No, but MD Teli is also there, no?
That is on
UDCT.
The ICT, but I think it is better here. Is there Kiran Rade? Direct message is there, no? Mangesh 95 Teli at yahoo.com.
No space, no?
No space. No space.
Mangesh 95
Teli
at
yahoo.com.
It is there, Reena.
Thank you.
95 Teli at yahoo.com.
You have yourself typed it.
I have myself typed it, but it went to one of this one. Kiran Ranade, I don't know what to meet Kiran.
No issue.
You can see it and and
So
okay.
thank you, Dr.
Thank you
Teli.
so
Thank
much.
you, everyone.
Thank you.
Thank you, Sharmaji, RN Sharmaji. You have acceded to my request. Today I sent you the message and you have joined.
Yeah.
Thank you.
And
thank you, everyone.
Thank you so much.
You want to say anything?
No, I just
Dr.
wanted to say, you know, I know there are all stalwarts. Nobody should think that I did not take their names, but you know, because my lecture was so good. But I respect each one of you. And only I tried by share. You know, as somebody said that it is basics. And it is basic because they are available. Nothing, you know, today the Google is the master for it. But still you need a teacher to explain. So thank you so much.
And at last, something about Sarve Bhavantu Sukhina.
Yeah, so that's where
from your side.
Thank you very much. Some other time, you know. But Vasudhaiva Kutumbakam is good,
right,
you know, and consciousness. My consumer, producer, supplier, student, no difference. You know.
Thank you, RP Sharma Bhai Sahab.
Thank you so much. I take leave of you.